So this is problem number 12. During a steady flow process, the pressure of the working substance from 1 to kPa to 200 kPa drops from 1 to 200 kPa. The speed increases from 120 meter per second to 1,200 meter per second. The internal energy of the open system, yan ha, sinabi niya na open system, that is, meron kang flow. It decreases from 120 kilojoule per kilogram to 20 kilograms. And the specific volume increases ito yung 1, and then this is 2. Determine the work in kilowatts if the mass flow rate is 1.2 kilograms per second. So, mas maganda dito, lagyan natin ng diagrams. Okay? Paano pag naging negative? Kunin natin yung diagram niya dito sa nauna. Okay, may diagram siya dyan of the workflow. Kunin natin yung diagram. Yan. This is number 12. This is the diagram. Tandaan nyo, pag work done on the system that is positive, work done by the system that is negative, the heat added to the system that is plus, negative naman kapag heat is given off or taken out of the system. So, meron ka ng mga value. You list down all the values before you solve it. So, pressure 1 is 1,200 kPa. Pressure 2 is 200 kPa. Tapos, the speed increases from V1, 120 meter per second. V2 is 1,200 meter per second squared. Per second. The energy, internal energy, decreases from U1, 120 kilojoule per kilogram. U2 is 20 kilojoules per kilogram. Specific volume increases from, so the specific volume, ganyan, 1, 0.12 meter cube per kilogram. Ito yon, 1.2 cubic meter per kilogram. And then the mass flow, ang hinahanap niya is the work. Dapat ang work mo dyan, if the work is negative, again, that is done by the system. And then if work is done on the system, that is positive. Okay, dapat i-denote nyo if that is done. Okay, done or done by. So, by steady flow equation, the work is equal to, okay, yung change in pressure, energy, from 1 to 2, plus potential energy. Okay, delta KE from 1 to 2, plus yung delta U 1 to 2. Tapos, meron ka ditong work non-flow. Okay, the change in work from 1 to 2. Tapos, meron ka bang heat given off dyan? Okay, wala ka namang heat. So, plus heat, Q. Yan. So, cancel mo yung walang binigay. May binigay ka bang elevation change? Wala. That is 0. May binigay kang change in velocity? Yes. May binigay kang change in internal energy? Yes. Meron ka namang pressure and volume. This is delta PV to Delta PV. Yan. And then, wala kang binigay na heat exchange. So, 0. Now, we can resort with the calculation na without yung potential change and then yung heat addition or rejection. So, the work steady flow to work steady flow. Ang measure mo is the change in pressure and volume. That is 1 to 2. Okay. So, meron kang pressure dyan and volume. So, KE muna tayo. Mamaya na natin i-add yung mass. mag-a-add ka ng mass, kunin mo muna yung specific. Kasi lahat naman 'to lalagyan mo ng mass after, 'di ba? Para makuha mo yung, ah, talagang work sa kanya, hindi specific work. Now let us solve. So, V2 squared minus V1 squared divided by 2G, yan na yung sa KE, plus the change in U, U2 minus U1 plus P1 V1, mhm, P2 V2 minus P1 V1 over K minus 1. Eh, 'pag nauna yung 2, K minus 1 yan. Kapag nauna yung 1, 1 minus K. Then wala ka ng heat. So, proceed ka ng calculation. So, V1, kasya kaya 'to sir sa isang calculate? Let us try. V2 is 1,200 meter per second squared minus 120 ang pagkakaalam ko diyan. 120 meter per second squared. Square mo yan. Tapos 2 times 9.81 meter per second squared. Plus, excuse. So, pwede ko na bang i-multiply ito ng mass? Sige, diretsuhin ko na ng mass mamaya. Dulo na lang. Yan, plus U2, U1, U2, 20, 20 minus 120 kilojoule per kilogram. Plus, yung P2, V2, okay, dito. Yung P2, that is 200 kilonewton per meter squared multiplied to P2 V, yun, specific volume 1.2. 1.2 meter cube per kilogram. Hindi, sa baba ko na lang, lipat ko na lang siya para magkasya. Okay? Para magkakasya siya. Yan, plus. Natin yan. Ano yung P1? P2. Ayan, 200. 200 kilonewton per meter squared multiplied to 1.2 cubic meter per kilogram. Okay? Minus 1,200 kilonewton per cubic meter multiplied to 0.12 cubic meter per kilogram divided by K minus 1 ang ginawa ko dyan kasi nauna yung P2. 1.4 minus 1. And then, close bracket. You multiply it with the mass. What is the mass? 1.2 kilogram per second. 1.2 kilogram per second. Tignan mo muna, unit analysis ka. Dito, ang lalabas dito is maka-cancel meter per second squared meter. Meter ang lalabas dito. Tapos, meter. Okay? Tanggalin mo na to, wala pala yung 2. KE pala yan, wala pala yung 2G. Tinanggal ko yun. Pang Bernoulli lang yun. Tanggalin mo yung G. Then, ang lalabas dito, meter, kilogram, kilojoule. Ang lalabas dito, kilojoule. This is kilojoules. KJ. Dito, KJ. Dito, ang lalabas dito, kilonewton. Cancel. Cancel kilonewton meter per kilogram, kilojoule per kilogram, kilojoule per kilogram. Ayan, dito, kilonewton meter per kilogram, kilojoules per kilogram. Okay. And then, cancel out mo yung kilogram, 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 and then kilogram. Kilojoule per second is kilowatts. So, let us solve na yung work steady flow. Ay, mahaba talaga siya. So, 1, 2 squared minus 120 squared divide by 2. Sa dulo ka na lang mag-add nung 1.2 nung mass niya. 20 minus 120 plus yung buo. 200 times 1.2 minus 1.2 times 0.12. Divide mo ng 1.4 minus 1, bali 0.4. The answer is, yan. Tama ba? Ba't naging ganun? To 120 kilojoule. Kilonewton. Okay, meter cube per kilogram. Tama naman. Happened. Mhm. Ayun, meron tayo dito. Ito pala nagpalaki dyan. Dapat i-divide mo pa ito ng, nagpalaki dyan, nakita ko na. Ito, hindi to kilojoule. Dapat to di-divide mo pa ng 1,000. Yan, dapat ito di-divide mo ng 1,000. Yun na nagpalaki. So, dito sa dulo, tinitignan ko siya. Times 1,000. Yan. Ayun. Okay, equal to. That is negative. Okay, negative. Negative 852.8 kilowatts. The answer for work steady flow. Okay? Ganun lang siya. Ito yung nagpalaki kasi ito Newton. Okay? So, for number 13, a Carnot engine operating between 350 and 135 degrees Celsius produces 35 kilojoules of work. Compute the change of entropy during heat rejection. So, going back to your thermodynamics, what is Carnot engine? Carnot engine is the most efficient engine sa ating thermodynamics. And it has two processes. Meron tayong constant entropy and then constant temperature processes dyan. So, from your initial state, okay, sa PV diagram mo, at in your initial state, okay, mangyari is T1, okay, T1. Baliktad dapat mas mataas yung heat. T1 and then T2. From your 1 to 2, that is adiabatic heat addition. From your 2 to 3, that is constant temperature. Tapos, pangatlo, from your T2 to T3, that is heat rejection. So, this is the TS diagram ng iyong Carnot Engine. Ngayon sa TS diagram, mas magandang makita dito yung work net. Nandito yan sa loob nung mabubuo niyang cycle. Makikita nyo dito na yung kanyang processes, meron kang dalawang isothermal and then dalawang isentropic. Dalawang isothermal and then isentropic processes. So, maganda bang basihan yung kanyang PV diagram? No, yung PV diagram kasi niya medyo malilito ka. Mas maganda dito ka na sa TS diagram mag-resort. Okay? So, meron kang given na T high. Okay? This is T1. Dapat to ginawa mo na lang TH. This is T low. Okay? And then S1 and then S2. Compute the change in entropy during heat rejection. Saan po ba nagkakaroon ka dyan ng heat rejection? The heat rejection process happens here. QR. Dito nangyayari yung heat input mo, QA. Okay? So, meron ka dyang the change in entropy. Pag Carnot Engine. Ayan. So, the Carnot Engine, like other heat engines, ang efficiency niya is equal to work net divided by QA. Okay? And that is also equal to the 1 minus TL over TH na formula. Basihan mo yung kanyang temperatures. Since yun lang naman ang madalas na given dyan, temperatures. And then this is equal to TH minus TL divided by TH. Okay? Pwede mo ring basihan dyan, ito, yung equal sa TH minus TL over TH. Multiply mo, saan ang galing yung delta S, sir? Okay, delta S, delta S. Kaya na-cancel lang yan. Nandito lang yan sa delta S. Okay? Kinancel mo ito. Kinancel mo yan. Kaya naging TL minus TH. So, binabacktrack ko lang yung derivation niya. May solution ako dito. Gagawa ko lang. Ayan. And tandaan mo na pwede rin itong the work net. Okay, take note of this. The work net is equal to QA minus QR. Okay? And then this is equal also to TH minus TL multiplied to delta S. Tignan mo ito Ayun 'Di ba TH minus TL, that is work net. Ayan work net over QA. So, ibig mong sabihin, sir, yung QA is equal to TH multiplied to delta S. Yes. TH multiplied to delta S. And then, ganun din naman yung QR mo. Yung TL delta S. Ngayon, pag pinagsama mo dito, maka-cancel mo yung delta S. Now, anong hinahanap natin dyan? The change in entropy during heat rejection. Meron ka bang QR dyan? Wala. Pero meron kang TH and TL. So, pwede ka na agad dumiretso sa worknet. Nakuha mo na ba si worknet? Hindi rin, sir. Si QR, nakuha mo din ba? Wala kang QR. Okay, yun ang problema mo. So, unang gagawin mo dyan, you have to find the efficiency ng iyong engine. Kasi meron ka namang TH and TL. The efficiency of the engine is equal to 350 minus, ayun, meron ka palang work na 35 kilojoules. Okay? Meron ka ng work net. Doon na lang tayo magbase sa work net. 35 kilojoules. Okay? dito, 35 kilojoules of work. Wala, may seconds ba? Wala. Kilojoules lang ang binigay. Equal to TH minus TL. TH is 350. Okay. 350 and 135. Minus 135 degree Kelvin. Ngayon, multiply to delta S. Ang hinahanap lang natin, the change in entropy. During heat rejection, pareho lang naman yun eh. Ay, pareho lang naman yan. So, that is delta S is equal to 35 kilojoules divided by 350 minus 135 degree Kelvin. Kilojoules of work. Yan, kilojoule per ano lang, Kelvin. Delta S is equal to 35 divided by 350 minus 135. The answer will be 0.1627 or 0.1628 kilojoule per degree Kelvin. That is delta S. Ganun lang kadali. Paikot-ikutin mo lang yung Carnot engine or the Carnot cycle. So for number 14, a heat engine is operated between temperature limits. Binigyan ka temperature limits. 1,275 degrees Celsius and then 244 degrees Celsius. Engine is supplied with, yan, 8,456 kilojoule per kilowatt hour. Find the Carnot efficiency. Hindi mo na kailangan gamitin to. Meron ka ng temperature limits eh. Okay? O, the efficiency is equal to TH minus TL over TL. Or, simply, ganito na lang. 1 minus TH. Hindi, TL yan. TL yan. TL divided by TH. Efficiency is equal to, okay, 1 minus TL. Kailangan, gagawin mo dito is, tawag dito, gagawin mo siyang absolute. Okay? Absolute. Ito muna. Ba't ko ginawang ganito? Kasi dito mag-absolute ka pa sa dulo. Okay? Dito kahit hindi na. Pakita ko. So, TL, 244 plus 273 divide by 1275 plus 273. Okay? Tignan mo yung pinagkaiba nila dito sa solution nito. Ito muna gagawin ko. This one muna. Ito muna. So, equal to 1 minus 244 plus 273 divided by 1275 plus 273. Okay. The efficiency now is 66, di ba? 0.6660. Okay. Or 66%, 66.6. Paano naman kapag sinolve mo yung ito gamit yung nasa taas, TH minus TL? Since that is change in temperature, hindi mo na kailangan to i-absolute. So, as is, 1275 minus 273, hindi, 273, 244. Ang baba na lang ang lalagyan mo ng absolute. So, 1275 plus 273. Ganun lang ang pag-solve niyan. 1275 minus 244. 1, 2, 7, and 5 plus 2, 7, 3. Same lang yan. Okay, the same lang. Yun lang din ang sagot. Okay, that is for problem number 14. How about number 15? A Carnot engine requires 35 kilojoules per second from a hot source. Okay? That is, I think that is Q. From a hot source. That is Q. Q. 35 kilojoules per second. The engine produces o di ibig sabihin that is work, 15 kilojoules per second. And the temperature of the sink, heat sink, that is 25 degrees Celsius, that is T low. Imposible namang T high yan. What is the temperature of the hot source? Now, punta ka ulit sa efficiency. Okay? Efficiency is equal to Q, basihan mo ta, QA minus QR over QA. Okay, simplify natin. 1 minus QR over QA. Wala ka namang QR, may QA ka. Pero pwede rin tong 1 minus TL over TH. Ayan. O, tignan nyo. E is equal to work net over QA. Equal mo dito. Okay? Dalin mo dito yan. 1 minus TL over TH. Ang hinahanap mo is hot source. Meron kang TL, meron kang QA, meron kang work net. Okay? By algebra, padaliin natin. So, ilipat ko TL over TH equal to 1 minus work net over QA. Bago kayo maglagay ng mga values dyan, kailangan ayusin nyo na muna sila kung ano yung hinahanap mo. So, TH ang hinahanap ko, TH equal to itong buo, okay? O, TL divided by 1 minus work net over QA. O, di ba? Meron ka ng final form. Pwede mo nang gamitin dito yung mga values mo. TH ang hinahanap. So, TH in, nakalagay ba dyan Kelvin? Degree Celsius. Okay? Ayan, lalabas dyan, commonly is in degree Kelvin. So, ganito ang gawin mo. Divide mo, TL. Okay? What is your TL? That is 25 plus 273. Ang lalabas dyan, Kelvin. Tapos, 1 minus work net, yung 15 kilowatts, kilojoule per second, divide by the hot source, 35 kilojoule per second. Oh, ang lalabas Kelvin. O, di minusan mo ng 273 para maging degree Celsius. Yan. Cancel natin yung same units. Itong kilojoule per second, kilojoule per second. O, ngayon minusan mo ng 273, ang lalabas na matik dito is, lalabas dyan kaagad is degree Celsius. T high. Okay. Solve mo na. Nagawa mo na yung algebra, nilagay mo yung value as is, ganun na ang solving niya. Mabilis lang. 273 and then 1 minus 15 divide by 35. Okay? Minus 273. Ilan ang sagot dyan? 248.5. Okay? Same lang. 248.5 degrees Celsius. That is the hot source temperature. Okay? That is for problem number 15 and let us take a 5-minute break muna. Water break.